Hi all! I'm just going to go through the solutions to the AP2 for you because I'm not there today. I'm here, but I'll pop in and see you, but I'm not there. Right, if you want to access this file, if you have a look on the left-hand side here, it's in your Further Maths notebook, class notebook on Teams, and it's in the assessment sections there under AP2. Right, I'm going to do some questions together and then some questions on their own, so you don't have to watch all of it. So I'll do the multiple choice ones first, okay? Right, and then I'll do the rest of them in separate videos. So let's get this screen where we want it. Right, so find the imaginary part of this. On the whole, this question was done really well, so I'm not too worried about this at all. But what all you need to do for this, if you can't remember, is you're going to multiply the top and the bottom by the complex conjugate of what we've got on the bottom. So you're going to times the top and the bottom by, okay, the top and the bottom by the complex conjugate. So you're going to times the top and the bottom by 1 plus I. And the bottom by 1 plus I. And that will give you on the top 5 plus I plus 5I, so plus 6I plus an I squared. And on the bottom, you're going to have 1 minus I squared. So minus I squared is 1. So you're going to have 1 add 1. So you're going to have 2 on the bottom. And obviously I squared is minus 1. So that will give you 4 plus 6I all over 2, which is 2 plus 3I. So your imaginary part there is going to be 3. Okay, now the next bit is one of those things that you just have to learn. If you're doing the product, so you're multiplying two complex numbers together, so W times Z, we multiply those moduluses together at the start, so we'll have 2 times 3 at the start, and we add the angles, so we should have cos of alpha plus beta plus I sine alpha plus beta. Okay, so we're going to have 6 lots of cos alpha plus beta plus I sine alpha plus beta. Okay, if that was W over Z, you would divide your moduluses and you would subtract your angles. So just going forward, make sure you know those, okay, and so on. Okay, number 3. Which of the following transformations is represented by the matrix? Right, so it doesn't do anything to your x values, it doesn't do anything to the z values, but the y values go from positive to negative. So the y values go from positive to negative. So that means that we are reflecting in the plane y equals 0. So those y values are going from positive to negative. If you're not sure, pop it in your calculator, pop some coordinates into your calculator, any coordinates, so just create a coordinate matrix. So you could have, I don't know, 0, 0, 0, obviously that's going to stay at 0, 0, 0, and then you could do like 1, 1, 1, see what happens to that, 2, 2, 2, see what happens to that. Multiply those in your calculator and you should see what's going on then. Right, question 4. This is a cracker of a question, I love this question. Right, so with factorial basically means, so R factorial means that we're doing R times R minus 1 times R minus 2 times R minus 3 all the way down until you get to 1. Okay, now you've done that in normal maths, it's part of the binomial expansion formulae. Right, so what we're going to do is use that to show this inequality here. Right, so here we've got 1 over R minus 1 factorial as your first term here. But R minus 1 factorial is the same as all this. So it's the same as R factorial, except you're not timesing it by the R at the start. So if we wanted to, we could say, right, R minus 1 factorial is R minus 1 times R minus 2, and so on, all the way down, all the way down to 1. So if we wanted to replace that with something like we know here, if we times this by R, and we do R times R minus 1 factorial, and R times all those other ones, R minus 1 times R minus 2, and so on, we've now got something that's equal to something that we want now. Right, okay, so now, so this, we can replace this 1 over R over, so 1 over r minus 1 factorial. If we times the top and the bottom of that now by r over r, we're not changing the value of it, but that now becomes r over r times r minus 1 factorial, and that is the same as r factorial on the bottom. That's just the definition of r factorial. So we can replace this first term here, this one here, with r over r factorial, and then we're taking away 1 over r factorial, which we know, because we've got a common denominator, is the same as r minus 1 over r factorial. So all you needed to do for that one was write that 1 over r minus 1 factorial is the same as r over r factorial. And then it all comes out really nicely, which is why it's only worth 1 mark, really. Okay, so for part B, using the method of differences. So method of differences, we should know that. We should know what that is all about. So even if you can't get the first bit right, we should be able to do the second bit. So the method of differences is going to replace this r minus 1 r factorial with this here. Now, even if you couldn't do the first bit, you should be able to do the second bit, because all that is the same as doing the sum between n and r equals 1 of what's on your left-hand side here. So 1 over 1 minus r factorial, so 1 over 1 minus r factorial minus 1 over r factorial, because that is what's on your left-hand side here. Okay, right, now method of differences you should be familiar with. So we start off when r equals 1. This is equal to 1 over 0 factorial minus 1 over 1 factorial. So we're just subbing r equals 1 into this formula here. And then because we're doing our sum here, so it'll be that plus, because we're adding, we're summing, and then we sub in r equals 2. So that'll give us 1 minus 2. So that's 1 over minus 1. Have I written this right? 1 minus r. Oh no, it's r minus 1. Didn't think that looked right. Sorry, r minus 1 there. Oops. So that gives us 1 over 1 minus 1 over 2 factorial. Sorry, right. So then that gets, when r equals 3, we add our next term on. So 1 over 3 minus 1 is 2. So 1 over 2 factorial minus 1 over 3 factorial. And we carry on in this manner until we get to our last term. So when our last term is when r equals n, and we've added all these up so far, and we end up with 1 over n minus 1 factorial minus 1 over n factorial. And if you remember this from when we originally did it, you can see that these terms are going to cancel out. So we're taking away 1 over 1 factorial here, but then we're introducing it again there. So we're going to take that away, that balances out with that one. That minus 1 over 2 factorial plus 1 over 2 factorial goes away, and that pattern will carry on all the way down until you're just left with that term there and that term there. So we're just left with 1 over 0 factorial. If you pop that in your calculator, that's just equal to 1, minus, and then our last term here, which is 1 over n factorial. And then that is in the form that we want it in. So a is equal to 1, b is equal to minus 1. We have done method of differences. If you can't remember that, it probably will come up, and it's worth quite a few marks, that, so make sure you get good at that, okay? And I'm going to make the next bit in the next video.